Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 16th video in the Introductory Programming in Java full course and the 7th video of Lesson 3, Branching Structures in Java. In prior videos, we've looked at relational and logical operators, comparing strings, Boolean variables, checking ranges, if-else statements, nested if statements, complements of Boolean expressions, and assert statements. In this video, we're going to look at the best ways to test for mutually exclusive conditions using serial if statements and switch statements, and we'll also take a look at an if statement shortcut called the ternary operator. Let's get right into it. In many programming situations, you'll find you want to choose among mutually exclusive options. For example, you'll want to know what item the user chose from a menu, or which decade their birth year falls into, or what kind of item they're borrowing from the library, and you'll want to do something different for either each value or each range of values. We say cases like these are mutually exclusive, meaning if one option is chosen, the others can't be chosen. For example, if you were born in the year 2000, then you were born in the decade 2000 through 2009, or you might say the aughts. You can't have been born in the 90s or the 2010s or the 50s. The year will fall into only one decade. When we are testing for which mutually exclusive option was chosen, we'll want to use either a serial if or a switch statement. A serial if is always going to be an option, but you can only use a switch statement if you are testing for specific integer or text values. So let's start with a serial if, as it's more general. Here I have a program called Simple Quiz Serial If.java. It's really simple. The program asks the user one multiple choice question, which you may remember from our video on logical complements. It then gives feedback on the user's answer. If I run it, and let's say I enter A at the prompt, which is wrong, I'm given some feedback, or is not the complement of and. Okay, so the interesting part here is the feedback part. The user is going to type A or B or C or D, or, importantly, something else. Remember that users don't always follow directions, even when they're trying. But the important thing to know is that whatever they type, it can only be one of those things. They're mutually exclusive. So once we've handled the thing they've typed, we don't want to keep testing to see if they typed the other options. So to do that, we write a serial if statement. We start with an if and put a condition after the if. If you're trying to be really efficient, put the most commonly chosen option first. So if I'm optimistic, I'd handle C first because C is the right answer. If you put the most commonly chosen option first, then your program will execute fewer tests more of the time. I've put these in order for readability. I'm handling A, then B, then C, then D, then everything else. So after if answer equals A, in the curly braces, I have a print statement with feedback. And then an else if answer equals B, feedback in curly braces. And then else if answer equals C, feedback in curly braces. Else if answer equals D, feedback in curly braces. And then finally an else. This else will catch anything that wasn't already caught. So anything that isn't A, B, C, or D. And I've put an assert in here to that effect. I want to briefly note the indentation for the serial if. Keep all of the else's at the same level of indentation as the original if, or of the original else, if you put the else's after the if's closing curly brace, as I do. Do not indent each else further than the last. This is all one single if statement. So how does this work? Let's say the user types A. Then we go to line 25, if answer equals A, that's true. The conditional code on line 26 executes, and then the rest of the statement is bypassed or skipped. The else's are all attached to this original if. And we could have as many as we need. In this case, we need to test 4 cases and then a catch-all else at the end, a default if no other cases were true. Suppose the user typed C. Then we go to line 25, if answer equals A, that's not true. So we go to the first else if answer equals B, and that's not true. So we go to the next else if answer equals C, and that one's true. So we execute the conditional code and bypass the rest. So the tests are executed in order until we find a test that evaluates to true. And then as soon as one of the tests is true, we execute its conditional block, and then we bypass the rest of the if-else-if block. So it will test each one in order until it finds a true condition, execute that conditional code, and then it jumps to the first line of code after the block. Now suppose none of them are true. Then it tests A, then B, then C, then D, and then it gets to line 36, else, and it executes that code. There's no condition, it's a regular else. It executes if none of the ifs in its block were true. Note that you don't have to have that default else at the end. You could do nothing if none of the tests are true. How you structure this depends on the problem you're solving. I recommend you step through this in the debugger and watch how it behaves for different inputs. I'd also suggest you rewrite it as separate if statements and step through that in the debugger. Separate if statements are very inefficient because each one will always execute. Now let's look at this same problem but solved with a different structure called a switch. A switch is also a good structure for mutually exclusive conditions, but it is more limited in how it can be used, and there is one tricky part that trips up many students and even experienced programmers sometimes. So here's a program called simplequizswitch.java. It asks the same question, but I'll say one thing you might have noticed in Simple Quiz serial if is I was converting the user's answer to lowercase and then grabbing the first character from the answer and storing it as a char using char@, and passing in index 0. I'm storing the first character of the user's answer as a char in this switch version, but I'm not converting to lowercase, because this is something that switch statements can be good at. So we'll edit this in a minute to handle both cases of input. I'll show you how. But first, let's just look at the switch and talk about the syntax. A switch statement begins with the keyword switch, all lowercase, and following that, in parentheses, a variable. The variable can be of type byte, short, char, int, or string. This is the variable that we're examining in this statement. Then there are a series of cases. That is the keyword case, all lowercase, followed by a value that the variable is going to be compared to, and then a colon. It's very odd syntax for Java. It seems almost Python-like. After the colon, there can be any number of statements that will execute if the variable value matches the value after the word case. So, for example, on line 26, we have case A. The code on line 27 will execute if the variable after the word switch, in this example, answer, is equal to A. Now this is very important. You'll notice the keyword break after the print statement on line 27. The break causes the flow of control to jump to the first line of code after the switch statement. In this switch statement, we have 4 cases, one each for the value of answer being equal to A, B, C, and D, and then a default. Okay, so how does it work? When control reaches line 25, the first line of the switch, Java will begin comparing the value stored in the variable answer to the cases in order. As soon as it finds a match, it executes the code after the colon. But here's the catch. If there's no break, Java will continue to execute through the end of the switch statement. This is referred to as falling through. So think of the case as an entry point, but it's not an exit point. If I had no break on line 28, if the value and answer were A, Java would execute line 27 and line 30. I'll demonstrate that by commenting out the break, running the program, and entering A at the prompt. Notice that it executed the print statements on both line 27 and line 30. It didn't continue on with the other print statements because it then reached the break on line 33 and exited the switch statement. It is a very common error to forget to put the breaks in your cases. If your program always seems to be handling more cases than it should, it's possible you forgot the break statements. However, falling through can be useful. For example, we can handle both uppercase and lowercase answers from the user by listing both cases before we handle them. So if I write after case lowercase a, case uppercase a, Then both lowercase and uppercase a will result in the print statement on line 27. I'll put that code in for each case, so the switch statement can handle both uppercase and lowercase letters. Both serial if and switch statements are useful when you have a set of mutually exclusive options, where only one will be chosen, and you will take a different action based on each option. A serial if will always be an appropriate choice. A switch can be slightly more readable, but it's less powerful. You can only use a switch statement to test for equality. You can write any Boolean expression in an if statement. You can only use a switch with certain data types, discrete data types, character, string, and integer data. And it's easy to make a mistake with a switch and forget the break statement. But despite those tricky aspects, you will want to know how to use this because you'll see it in other code, and because it is a good choice in the limited situations where it's appropriate. Now, I want to show you one more kind of conditional statement called the ternary or conditional operator. And like the switch statement, this operator has limited use relative to an if statement. However, it is kind of nifty when it's an appropriate choice. If you like terse code, you're going to like this statement. Let's revisit averagealtitude.java. This is a copy of the program called averagealtitude_ternary.java. Recall that in this program, we have a Boolean flag called has non-positive value. We start that flag out on line 12 with a value of false, and each time we obtain a value from the user, we check if it's less than or equal to 0, and if it is, we set the flag to true. So there are 3 opportunities to change this flag to true if there's invalid input. Let's look at the first instance, lines 19 to 22. We write, if altitude 1 is less than or equal to 0, has non-positive value equals true. We can accomplish this same thing in one line with the ternary operator. I'm going to replace this with that code. So the goal of this code is to assign true to has non-positive value if altitude is less than or equal to 0. To do this, I'll write has non-positive value equals. Then I put the test, altitude 1 less than or equal to 0. And you don't need parentheses around the test here. And then question mark. And then I put the value I want assigned if the test is true. So true, and then colon, and then I put the value I want assigned if the test is false. So be careful here. I don't want it set to false. I want it to keep whatever value it had before the assignment statement. That's because it might be false, but it might have been changed to true from one of the prior bad inputs. So I don't want to undo that work. So I'll write has non-positive value, and then of course the semicolon. This is another example of some weird Java syntax. So let's change the other 2 statements to ternary operators and run the program. And let me just type 1 and then 0. And I get the error that 1 or more altitudes is 0 or negative. Let's review the syntax of that one more time. This expression evaluates to a value. So in this example, I've put it to the right of an assignment statement. We begin with the test, in this case, altitude 1 less than or equal to 0, or altitude 2 less than or equal to 0, or altitude 3 less than or equal to 0, followed by a question mark, followed by the value the expression should evaluate to if the test is true, followed by a colon, and then the value the expression should evaluate to if the test is false. Let's look at another example. Here's moon weight calculator choice. This is a copy called moon weight calculator ternary.java. Now, in this program, the user enters 1 for a calculation of their weight on the moon, and any other number for a calculation of their weight on Mars. But down on line 47 in the print statement, we write your celestial weight is, which is kind of a cop-out. Let's change that so it writes your weight on the moon is, or your weight on Mars is. And of course, we could do that with an if statement, but let's do it with a ternary operator. So I'm going to change this to a printf, and write in the format string, your weight on %s is %.1 f period /n. And then for the second argument, which will be interpolated to the 0.1f, is celestial weight. But what about the first argument, interpolated into the %s? We can use the ternary operator because it will evaluate to a value. So we want it to evaluate to the string the moon if the value in choice is 1, and otherwise we want it to evaluate to Mars. So for the first argument, I can write the test choice equals 1, question mark, the string the moon, colon, and then the string Mars. And I can run that and enter 1 and 100. And I get the familiar weight of 16.5, but it says on the moon. And I can run it again and type any other number. I'll type 0 and 100. And then I get the weight on Mars, 37.9. So that's pretty cool because it evaluates to a value. So you can put it anywhere you need a value and you can get a different value based on a condition. As usual, I have included a few auto-graded exercises in the description of this video so you can practice with the code here, and the code is available in my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.